the difference between selling books or selling a PlayStation versus selling clothes or shoes. And she says that fashion is a language. And if you think about it, it's actually your presentation letter to other people's, which means that it has a strong emotional component. So whenever you have an important appointment, either it's a date or it's a job interview or you have a celebration, you want to look good and you want to wear something that gives you confidence for that moment. So that generates a lot of questions that you wouldn't ask yourself if you were buying a book or you were in a physical store. So some of the questions that most of our customers have to solve are not only in Amazon but in any other fashion e-commerce page is, hey, will I find the style that I like in this store? Is this product going to fit me? Mahima, if you can advance, please. Is the product that I'm going to purchase made of good quality, or will it tear apart if I wash it, or it will die? Can I return it for free? That's a super simple question. What about other colors? What about other sizes? What about the fit? What about this brand? Because Amazon has thousands of brands, and not all the customers get to know the full extent of our catalog. So the exciting thing about all these questions is that there is no one size fits all. And the problem space is super complex. So it's actually a perfect land to try new things from different approaches and multiple angles and see which one works best, which one doesn't work, or which things work in the middle, and you need to iterate. So for this question, Amazon will say that we approach this in two different ways. One is we want to make Amazon the top fashion destination for customers, and also make the shopping experience fun and friction-free. Next, please. So what makes Amazon making the top fashion destination? And perhaps some of you never realized that Amazon sells clothes, but you can find anything on Amazon, from clothing to shoes to jewelry. So making Amazon the top fashion destinations means that we want to create content that inspires our customers. And by inspiring, I mean that you want your customers not only to purchase things, but also go back for the joy of having a good time. Think on Instagram. Many people, they just go to Instagram to pass some time there. That's what we want to drive with the changes that we are doing in Amazon. So in this slide, you have 4 examples of experiments that are mainly driven by our business development managers. One is influencer network, is likewise Instagram, but actually it solves one of the problems in that space, that everything that is presented from our influencer network has to be shoppable in Amazon. Or in Instagram, you can find things that there is no shop, or they are out of stock. So creating these influencer networks helps to solve this problem for customers that they just want to get an inspiration, they see an outfit, and they want to purchase the complete outfit. Then we also have a partnership with Vogue and fashion. This was launched after COVID-19 lockdown, and basically it helps new designers to get visibility into a mainstream channel. Before this, any emerging designer had to sell their clothes in small shops or niche shops, which were outside of the main public. This project helps to fix that pain point, and actually allows these emerging designers to showcase their work to millions of customers in an easy way. Then we also have Madrid Fashion Week. that this has also happened for other fashion weeks in the world. And what the business team has done is that outfits that are presented in the catwalk are available immediately in Amazon. So this reduces the time to market on traditional pret-a-porter model, where the designers and stores had to agree on the volume to manufacture because customers couldn't pre-order. With this situation, that problem is fixed, and also allow our customers to be according to the last trend. And last but not least is also the drop, which we saw emergent designers, we saw established designers in catwalks, and here are influencers that are not part of the influencer network that I mentioned before, that want to design collections and sell them through Amazon. This allows these people to follow an agile business model because it doesn't require them to do any upfront investment, and they can use the technology that Amazon has and the structure that Amazon has to create the collections and sell to the public in a easy way. So although all these initiatives are driven by our business partners, that creates complex technical problems because you have to scale this. Okay, so just think about on how will you rank all the new content that is generated so it's fresh and it aligns to the current season or the trend in style or in color. And also whatever you're showing, as I said before, needs to be available for purchase in Amazon. Given the volume of items that we move daily, you need to automate this, and you need to predict what items are going to get out of stock, so you can update all the websites without human intervention. Then, as you are creating more content, you want to personalize this content for customers, so they can start building a relationship with these emergent designers, with influencers they allow to follow and get more information from them. And also Amazon, remember that it's not only the website, we have Prime Video, we have Alexa, and all the content needs to be available in all platforms. Okay, so think on this slide while we transition to the next one, that is, how will you blend all this new content with the existing customer journey and transform the e-commerce traditional model into a social commerce place? The good thing of most of the issues that I described is that our platform teams already create the tooling necessary to develop once and deploy everywhere. So moving to this slide is, how do we make shopping fun and frictionless, and blend the content that other customers create or other influencers create into the shopping mission of our customers? So there are a lot of initiatives, but we can divide in three big categories. One is boost product discovery. In these categories where it falls what we saw in the previous slide, but actually it's only one small piece of the puzzle. The real challenge here is that how do you surface all brands and millions of reference to the customers so they can quickly navigate and find what they are looking for with any available mean that technology provides. So here we have three examples. The first one, the shop by category. This is a smart filter. It's a filter that is driven by ML, so it automatically understands the context of the customer journey and updates the filter, so as the customer goes deep into the selection, the filters get updated are meaningful to them. So they will start with choosing the department, and then perhaps they will select whether they want to dive into shirts or shoes or jeans, move to the style or a color refinement. So every time that they take an action, they have new information to move forward within this path and never reach a blocking point. The second one that you see on the bottom left corner is the Style Snap. This uses computer vision to find products in Amazon similar to the ones submitted either through an image or in a photo. So basically, you can just get your mobile phone, go into Amazon app, and in the search bar, you will see the icon of a camera. You can take a picture of anything, and we will find any reference that is similar to the things that you send to Amazon. And the last one is reducing the cognitive load. This is also another area where we are investing a lot, that we use site analytics to assess the overhead and process information in a page. And we use that information to drive our CX. So customers looking at the results will take less effort to compute and see if there's something that catches up their eye. The second category that we can discuss is the decision making around fit, for example, where customers, like brands, have different sizes. They have different meaning of what an ML, what an L is. So we have a whole team trying to infer whether something is going to fit in one of our customers, and they basically take information in our catalog with the dimensions, and they cross-reference with the reviews that we have in our page to understand whether the fitting is going to work for one of our customers or not. And the second project here is the styling ideas that I will combine with the innovate on the business model. But this is a clear example on how we scale things in Amazon. So on the business model, first, we have Prime Wardrobe. That's a project that we launched in 2019. And basically, we allow customers to try for free up to 7 items at home. They got delivered in less than 24 hours. And once the products are returned to the fulfillment center, then Amazon actually invoices the customer. So the customer doesn't have to pay anything in advance. As you can imagine, it creates a lot of interesting areas to explore with machine learning about fraud risk and abuse scenarios. And the last one is the personal shopper that ties to the styling ideas, where we put a group of personal shoppers to start making recommendations for our Prime Wardrobe customers. They only had to fill in a questionnaire with what was their preference, how they like to dress, and then what we did is, based on that small sample from our Prime Wardrobe customers, we started scaling this with machine learning to create styling ideas using similar products through computer vision. So if you got a jacket, then we found similarities to that jacket and start scaling the basic ideas that were proposed to our Prime Wardrobe customers in an automatic way and sell them to other customers in other parts of the journey. So given this, that was the quick introduction on things that we are doing in Amazon to reinvent the fashion experience. And I will hand over to Mahima to continue with the dive deep in the use case.
Thanks, Alvaro. So moving on to the next part of the presentation, I'm going to briefly talk about a few common technical challenges that we face at Amazon as a development team. And then I'm going to talk about one technical challenge in particular with the help of a use case. So let's start. So speaking about a few common technical challenges that we face here, one of them is scaling our platform. So Amazon operates at a very huge level. It has millions of customers, and which only makes sense that it has Amazon retail website or other services like AWS or Prime Video has a huge amount of traffic. So it's very important on our part as a tech team to be able to scale our platforms so that we can serve that huge amount of traffic. Big data problems. Again, on Amazon retail website, there are millions of products that are enlisted, which makes sense that we have to tackle with a lot of big data problems as well. For example, keeping our data up to date, data inconsistencies, or maybe removing duplicates from the data. Internationalization. Like I mentioned earlier, Amazon operates on a very huge level. It does business globally, and it is not just concentrated on a single marketplace or region. So we really have to make sure that whenever we introduce a new feature, we need to make sure that we configure our code in a manner so that we can easily make that feature global and it is not concentrated to a single marketplace or region. One of the most important and difficult technical challenges is latency regression. So we have to make sure that whenever we introduce a new feature, we are not causing any additional latency, or we are not causing any latency regressions to our existing platform, because that would be a very bad customer experience. And of course, there are many other technical challenges that we face here. But in this particular presentation, I'm going to talk about latency regressions in particular with the help of a use case. So let's talk a little bit more about latency regression. So starting from the very basic, what is latency? In a simple layman language, latency is nothing but it is the delay between a user's action and the web application's reaction or response to that action. And latency regression happens when the latency of any new experience or feature that we are adding to our existing platform exceeds the latency of the current experience. And our aim is to basically minimize or reduce the amount of latency regression that we might create whenever we are adding new features or functionalities to existing platforms. We have several tools at Amazon through which we can measure the impact of our features on the latency of existing platforms, and then we can make a decision whether we want to roll out this feature or not. So our aim is always to monitor the latency regressions with the help of these tools and make sure that we are not causing any additional latency to our existing platforms and hence causing bad customer experience. And not to mention, it is one of the most important and difficult technical challenges to solve. Now, talking about the importance of latency or low latency architectures. In the past, a lot of people have actually quoted the importance of having low latency architectures for big companies or organizations. According to me, it is especially very important to have low latency architectures in areas like gaming or maybe trading, where time is literally money. In short, latency is a huge deal for our customers. So I think everyone who's sitting right here today, we all are customers. We all must have shopped at Amazon before, or maybe use some other web application or software, and none of us would like to see loading signs like this or this. I think this is one of the most frustrating customer experiences. And looking at this. At these loading signs in whatever software or application you are using, it just the customers just tend to lose interest. And so this is what we want to avoid whenever we are adding new features to our platforms. Now we'll briefly talk about various ways of improving latency or minimizing latency regressions, or improving the performance of our softwares. So I think the goal is pretty simple, as you can see in the picture, that we want to reach our destination in the least amount of time that is possible. So instead of taking a long zigzag route, we want to take a direct route, and that is how we can, prevent latency. So there are several ways of doing that. One of the well-known way of improving the performance of a system is asynchronous programming. An example of which is Ajax, which is nothing but asynchronous JavaScript. So through asynchronous programming, basically, it enables a web application to send or retrieve data without impacting the display of the current web page. Another way of improving the performance of a system is parallel computing or processing. So it's always better to carry out multiple operations simultaneously than sequentially, because it saves a lot of your time. Another method is via pre-processing. So in pre-processing or pre-computing, what we do is we compute the data that a web application would need in future and keep it in a separate data store, so that whenever the web application needs that data, we can simply query for that data, and we don't have to do the computation on the fly. It would already be pre-computed or pre-processed and stored in a different data store. Another way to improve latency is browser caching, in which the browser basically stores the resources that are used by a web page locally, instead of calling them or retrieving those resources again and again. So in the subsequent slide, we'll finally talk about a specific use case. I'll be talking about a specific feature that we recently worked on. And I'll talk about that how by making simple design choices, we were able to minimize the latency regressions of the Amazon retail website, of the search page, basically. So the feature that I'm talking about is color swatches. So recently our team worked on a feature called color swatches, wherein the customers could actually see all the color options that are available for a particular product on the search page itself, so that they don't have to go to the detail page of a particular product to see in what other color options this particular product is available. So the problem was pretty simple. What we wanted to do was we wanted to display the color swatches or the color options of a particular product that are present. And we said that in the beginning that, okay, we'll show 6 color swatches to the customers, and the rest we'll represent by, say, +3 or +6 more colors. So in order to do that, the way our backend was configured was that our backend had color information for every swatch. So that means we had to call our backend 6 times in order to retrieve color information for these color swatches that you can see here. So what would be the best way to do that? The best way to do that would be to make these calls in parallel to the backend instead of calling them sequentially, which can reduce the amount of latency that we would generate. So by using a simple design choice of parallel processing or calling the backend in parallel for all of these 6 color swatches, we could reduce or avoid any latency regressions. Next, we said that, okay, we want to make these color swatches interactive. That means if I click on the green color swatch, I should see the dress in green color and not in black color. So in order to do that, this would mean that if a user clicks on any of the swatch, on any of the color swatch, then the product image should change. One way of doing that is to prefetch all of the product images and then display them as and when a user clicks on the swatch. But that would increase the overall page load time, because you have to prefetch a lot of image resources, most of which would not even be used because the customer would not end up clicking on each and every color swatch. So we said that what would be the best way to do it? We said that, okay, we'll do this on demand. That is, whenever a customer clicks on a particular color swatch, we will make a call to the backend to get the product image associated with that color swatch and then show it to the customer. In that way, we would not have to prefetch all the image resources, and we will make the call to the backend on demand. And a simple term for this technique that we used is Ajax. So through Ajax, we were able to again avoid any latency regressions, which would have been caused if we would have prefetched all the image resources. Next, we said that, okay, instead of showing just 6 color swatches, we want to show all the color options to the customer. So as you can see, there's a right pointing arrow, which means that clicking on it would show you other color options as well. And there are products at Amazon in which the color variations or the color options can go up to 50 or maybe 100 sometimes. So um, so in order to show like all the color options, we could not now make all of those parallel calls because our backend had a limitation that we cannot make parallel calls beyond a certain limit. So how would we solve it? We cannot make 50 sequential calls in this case, right? So we said that, okay, currently we have a database which stores information or color information at the swatch level. We said, what if we create another data source which would contain color information not at the swatch level but for the entire color variation family, which means that it's the same product but which is available in different colors, and we would store that information together in one data source. So this is called pre-processing or pre-computing computing of data. So what we did was we pre-computed all of this information before and stored it in a separate data source, so that whenever we search for something on the search page, then we would just query that data source, get all the color information associated with all the color swatches, and simply render all the color swatches on the search page. So that is pre-processing, and through that we could again avoid any latency regressions. So this was a simple use case that I told you guys about, and it just tells you that how by making simple design choices you can avoid any kind of latency regression, and you can also try to improve the performance of your system. So with this, we come to the end of our presentation, and we come to the next section of our presentation, which is Q&A. So feel free to drop in any questions. Either me or Alvaro would be happy to answer them.
So perhaps there's some question. If you are in front of your computer, try to unmute yourself or write down the question in the time room, and we will read it loudly and respond.
Guys, feel free to drop in any questions that you might have on the chat.
So we have one question here from Manuel. Hi, I'm a self-taught developer with more than 15 years of experience. I have 2 university degrees, one in commerce and another in market research. It is compulsory for as an engineer degree to apply for the jobs. I assume that you want to apply for software developer engineer job. I don't know if it's compulsory. What I can suggest is that you apply to any of the positions that are open around the title that you want to have, and the hiring process is quite nice. So if you're a good fit for Amazon, they will find you a position on perhaps another role that is still related with development. But my recommendation will be go ahead and apply. Okay.
We have another question here from Raul. Which programming languages do you use at the front end as well as the back end? So at Amazon, we actually use plenty of programming languages for sure, but the most frequently used programming language would be, I would say it's Java. And the one that I have used for the front end is JavaScript. So we actually moved some platforms to a new platform, and we are using JavaScript for the front end mainly, and for the back end, we use Java. But like I said, there's no limit to it. There are a lot of other programming languages that we use.
So we have other question. Is there any position for personal shopper or fashion stylist? Or it's only for developers? No, actually, those positions and that program is held in Seattle, and I think that also in California. So you will have to apply to Amazon US to get one of those, but they are not developers. They are actually fashion style people that actually works on fashion stylists. So I think that we are Mahima, do you want to take this last question while I post the link to go to the main session?
Okay, yeah, sure. Of the skills that you have acquired throughout your careers, which ones do you use the most at your job? Okay, I think that's a good question. I think working at Amazon, even as a developer, to be able to collaborate with multiple teams is one of the skills that I have acquired while during my tenure at Amazon. Because you know that Amazon is spread over the entire world. So there can be times when you have to interact with teams in different locations as well. So this is no technical skill that I'm talking about. It's just that the ability to be able to collaborate with teams throughout the world. I think this is something that we use here a lot, and this is something that I've developed during my tenure at Amazon. I think that's the last question, right? No, there's another one. Is there a front? Yeah, is there a front end developer position in Madrid?
So all positions that are open are usually published in LinkedIn. So just go to LinkedIn, look for Amazon company, and you will find any open position that it's in Madrid or somewhere else in Spain or Europe or United States. Thank everyone for attending this presentation. I hope that you had a good time. Don't forget that the event still continues with a day in the life at Amazon Madrid Tech and demystifying the hiring process. So just click on the link that I posted on the chime room, and you will be redirected to the other one. Okay. Thank you so much, and enjoy the rest of the day. Bye-bye.
Thank you, everyone. Have a nice day. Bye.